today's stream, we're going to look at Hasura schedule triggers, right? Um, it's been quite a journey for the event system with Hasura. First, we had event triggers, which were events in Postgres, and any action to your Postgres database, to your tables, would you can trigger a webhook on an action on that. So that was event triggers back in the day. And then we launched this feature called schedule triggers, which was time-based. So you could schedule events on a particular time, and either it could be like a recurring time, or it could be on a particular time in the future. So so that's broadly the journey, and it's been a interesting journey for the eventing system with Hasura, right? Um, so in today's stream, the idea is that we'll be looking at a calendar scheduling app. Very good example to showcase the schedule triggers feature. So there are a few things to keep in mind. So we'll go over the data models as usual. We have a simple event scheduling. Like there's an event table and there's an attendee table for each event. Think of it like just scheduling a meeting with your colleagues, kind of a use case. So you have to check for availability of the attendee, um, and then you have to do some kind of validation before you uh, do the event booking. So where the custom business logic portion will kick in. We'll be writing an action for that. And once we pass the validation step, we'll need to trigger some emails maybe to the person who is involved in the event. And we'll also probably want to send some reminder emails just a few minutes before the event begins. And so that would be a good use case for using schedule triggers API insight and action. So that's the typical workflow that we recommend. But then we'll go over all of this in a step-by-step process. Um, Looking at the comments again, um, um, I hope this time around I'm not muted. Um, Ivor says you're on mute is a top quote of 2020. I think 2020, uh, yeah, will probably has to end pretty soon now for me, at least. And I think everybody, I think would feel the same. So yeah, cool. So we'll start off with data models for this app. Um, it's a very simple uh, data model that we're going to focus on for this particular use case. We have obviously the user table as with any other app, with fields, ID, name, and email. And the core of this app revolves around event, um, which will have like a range of fields. You have the title of the event, and you have like a start time and end time of the event, and you have like whether it's a complete event for the day, or is it like a recurring event for the day, and a recurrence pattern. So if it's a recurring event, you need a pattern for when this event recurs at what interval, right? So there is a pattern involved in that, and there is like the pattern is following a spec. It's an iCal RFC spec, which follows the frequency and the interval in a format, right? So we'll talk about that, and and obviously event will be created by some user, so we'll have a created by column, and the event attendee will have the people who are involved in the event, which could be two or more people. So that's the combination of the event ID and the user ID. That will be the combination of the event attendee table, and the status would be whether the attendee has accepted the event or not. So that's where we are at the data model step. So let's go ahead and like create a project on Hasura Cloud. Let's call this um, schedule triggers demo, and I'm going to use uh, a nearby cluster. This is Asia. Oh, I think Asia is on the pay as you go, so I'm going to use the free tier US East. I have a long project name, so I'm going to stick to schedule triggers. Interesting. And as usual for the database, I'm going to use the Heroku Postgres add-on. And we have the Postgres configuration coming up ready. Cool. So let the project initialize for a few seconds. And meanwhile, I can show you the migration files involved in this. So there is this up.sql that we have, which is the initial migration system. That creates these tables that we discussed in the models, the event table, the event attendee, and the user table, along with some constraints being set for these, right? So that's just one up.sql in the migrations, and in the metadata we'll track these tables, and we'll have some kind of permissions configured as well. So we'll go over what the permission should look like for these. Now let's go back to the console. We have the project initialized. Right, so I've got my project URL up and running. So I'm going to copy this endpoint. Um, I've basically what I've did is I've cloned the repo. So I'm going to add that link on the banner. I'm going to also paste this link on chat so that all of you folks can look at it. Yeah, this is the link to GitHub repo. And yeah, so I've just cloned this repo. We have a Hasura folder there with the data migrations already created. So what I'm going to do is I'm going to do a Hasura migrate apply, and I'll pass in the endpoint. Oops, this is the GitHub URL. I'll have to recopy my project URL, which would be the schedule triggers endpoint. So first we'll apply the migrations, and next step would be to apply the metadata so that we have both of this ready. Cool. Let me know where are you joining from, which part of the world. So I'm from Bangalore, and since the cluster that I've created is in the US, I think the commands that I'm going to execute are going to take some time. Hopefully that will get better once I have the Indian cluster configured on my account. All right, so I have the metadata applied as well along with the migrations. Now you see the tables getting created here. Um, so this is just the data model that we saw earlier in the image. And we obviously have the APIs generated for us. Now that's the first step. I'm going to secure this instance so that nobody else does anything to this. Add a secret. This is like literally the first step I should have done when creating this cluster. All right, and I'm going to refresh this, then have the admin secret entered. Cool. So now we have everything configured here. I'm going to head to the data tab um, to go over the permission rules that have been configured for each of these. Um, Starting with the user table, I think the user permissions are pretty straightforward here. We have a pretty generous select permission. Typically, because in a calendar booking app, you would want to see the other users who are part of this application, the names of them, if you put in the email. So select will be unconditional. Uh, Insert, on the other hand, would have the session variable check before you insert. So this would be the ID of the user should equal to the Hasura user ID column, the session variable actually. And the permissions would be obviously for the name, email, and the created at timestamps. Um, and for the column preset, we can in fact, if we are using some session variable as the value, then we can do a column preset for the ID column as well. Right. So this can come from session variable called access user ID. So that's another optimization we can make, but that's broadly what insert and update would have. Um, Users can insert their own data with the authorization token, and they can update their own data as well for the limited set of columns, like for example the name of the user. Right. So this is just basic stuff on the user table. I'm going to go to the event table now, which will have a broader set of permissions. Obviously, select would have a slightly more generous permission system. Now, for insert, the the event can be inserted by the user who's logged in, and it will be assigned to the user who's creating it. So we have a filter which says created by has to equal to the session variable accessor user ID. Now this can be obviously be a column preset as configured here, and they can select some columns to be inserted. So the ID is auto-generated, so you don't need to give permissions for that. And the created by is a column preset, so you don't need to give permissions for that. But the rest of the fields will be part of your mutation, so you can give in permissions for this. Right. So this is roughly what the insert permission looks like for the event. And for event attendees, this will be having a combination filter. Um, Typically, for event attendees, either you should have created the event, or you should just be part of the event, right? To be able to select information from this table. So it's a combination or filter. So there is an event which has a created by equals to the session variable. So this first condition is just effectively saying that the created by user ID value has to be a session variable value, which is coming from X as a user ID. So the creator has to be the one who's requesting it right now, or the user ID who's requesting should be logged in and be part of this part of this attendee table. So this is a combination OR filter, and they can obviously select once they are having access, they'll be able to select all the columns. And for insert, it's the same condition that we had for select, and they can apart from the ID, which is auto-generated, they can do insert for all the columns. Similarly for updates, so I'm just keeping this. All right, so I'm just going to have to look at the comments related to the current project. I'd like to know what would you do if you want to revoke access to a user with an issued JWT, say user with a JWT role. All right, I think Ivor has a question about revoking access to an already issued JWT. Say a user with JWT has the role of a moderator and you want to downgrade it to user. Is a short expiring JWT the only solution? So yeah, so typically in a JWT setup, I would recommend having a short expiry and then using refresh tokens on the front end to keep generating tokens on a very short time span, typically every few minutes or so. So that's depending on how frequent, what kind of an application that is, and how frequently people will be logging in, logging out, and what kind of a scenario would that be. So, but in case you have actually like assigned a token with a longer validity and then you want to revoke it, here in this case, the only way is to have some. So at the Hasura layer, once there is an expiry time which is sent as part of the token, Hasura will consider it as a valid GWT, and then it will forward that request to the upstream, which could be either the database or it could be your custom logic, like an action or a remote schema. In case you have an action or a remote schema and you're forwarding your client headers, in that case, you can write some custom logic by just storing the session information in a Redis store or something, and then revoke access accordingly, right? So, but I think, yeah, we'll have to solve this at the issuing state, where we just give a very short time interval for the expiry token. I hope that answers this question. Um, all right, so coming back to our example, we'll have to now create an action which will create an event. So the thing with creating an event by using the raw mutation is that there's no validation that can be done here. So if you go to the schema, uh, if I have to create an event, I need to do a couple of inserts. I'll need to insert into the event table, and I'll also need to insert into the attendee table. So this is like a nested insert in the same mutation. But the problem here is that um, you cannot check for the availability of the attendee before actually scheduling an event, and you also want to schedule some events in a future time. Let's say, for example, the start date time is tomorrow, like 9 a.m., and the end date is also tomorrow 10 a.m. You want to send out some reminder emails to all the attendees just 5 minutes before the event. So now for this to happen, you need to have some events queued up, scheduled to run at that given time. So for all of this logic to take place, what we'll do is we'll create a custom action. We'll define a GraphQL mutation through action, and we'll perform some data validation on whether the event is a valid event, uh, whether there is availability for the attendees to attend and accept, and we'll also look at the dates and so on, right? So and the recurring state on the pattern. So all of these custom validations need to be done. and they cannot be done through the raw mutation that's available for you. Just going to close this one. So the raw mutation, um, which will have the insert event, will not have any validation. So what we're going to do is we're going to derive a mutation from the raw mutation that we have, which is auto-generated, and then we're going to once the action is derived, we will reuse the types that are there, and then we'll define a handler for that, right? So I'm going to call this um, insert event mutation, and we'll probably have some variables. So this would be event input, which would be, so we'll look at the docs for the type. So for insert event, um, the object type would be event insert input. Right, and as part of the objects, I'm just going to give it event input, and I'll probably need the affected rows coming back as a response, and as a returning, I would get back the ID. But I think I'll just stick to affected rows for now and worry about returning other data later. And so this is the mutation with the variables configured. What we need to do is we'll have to click on derive action now. So this will create a mutation and derive the types from the original event insert mutation. So this is just a bunch of input types that are coming from the auto-generated one. We can remove all of these, right? So the thing that we really want is just trying to insert the event with the raw fields, uh, and there'll be like attendees as well, which we need to insert. So this is how you actually derive an action from an existing mutation. So you will obviously have custom logic to perform for lots of cases. Uh, in that case, you will define the original mutation that you would have ideally done, and then you will derive an action through the console. So this is useful instead of actually directly going to the action and then defining your own mutation type. If you want to derive the action, that will give you the types from the original table and whatever Hasura basically generated for you initially. So you can just reuse those types and then start off as a base before modifying your mutation. Right, so that's where derive action will be pretty useful on the console. The next reason why this will also be useful is there will be a boilerplate code generated for you in the code gen for your actions. If you're using derive action, it will reuse the types over here, and then it will also give you the code to actually do the insert into the table. Because at the end of the day, after all sorts of validation and so on, you will eventually want to insert the event table with the same set of fields, except that before that insert mutation happens, you would perform some conditional checks and then do some validations, right? So, or probably even data transformations in some cases, right? So that's the usage of derive action. And since I've already applied the metadata and the migrations initially, I have the formatted action definition for this example. So in the other tab, if I show you now, this is the insert event that we tried out. Uh, you can call it create event. The action, the name of the mutation can be however you want to call it from your front end, however intuitive the naming of the mutation should be. So you can rename this to whatever makes sense for you to create an event. I am just going to call this create event in camel casing to make it easy. And the object input type is the event input, and the event input is just the list of fields for this particular table that are mandatorily required to insert a row. And apart from that, we have the attendees. So with the list of attendee IDs, what we can do is we can do a nested insert in the same mutation, and then it will create the row in the event underscore attendee table as well, right? So for that, we're just accepting another field called attendees, which will accept a list of attendee IDs. This is just user ID at the end of the day. But using this information, we'll be able to form a mutation, which will actually insert, which will do a nested insert into the next table, right? So this will be eventually one mutation call, which will make inserts into two tables. The first mutation will go into the event table, and the second mutation, the nested mutation, will go inside the event input table, right? So, sorry, the event attendee table, right? So that's the two mutations that will happen in the nested insert. And we're just defining the event output to be ID. We just we are just going to get back the ID from the database. It's a UUID type. So typically you can use a UUID to auto-generate an ID for you. So this is the type definition. You have a definition for the action, whether it's a mutation or a query. This time it's a mutation, and you have the types being defined for the input type and the output type. Um, and and finally, you will have the handler. This is your webhook handler that where we'll have the code written, the custom code written. We will leave it as it is right now. We'll deploy our action code on glitch and then come back here to modify this. I'm going to have this forward client headers to webhook enabled. So in case your front end actually sends in some custom headers, uh, and you want to probably parse it in your logic, you'll be able to do that as well. So this is why this is useful. And the kind will be synchronous in this case. Um, Most use cases you will probably end up using a synchronous action. Um, the difference between a synchronous and an asynchronous action is that with asynchronous, what you have is once you make a query or a mutation to the action, you will get an instant ID back from the server from Hasura. And then what you can do is you can use that ID to subscribe to further events that will happen. So it's more of an asynchronous use case where the UI is not blocked on the response, and you have like a subscription kind of a workflow, and that's where asynchronous event will be pretty useful. So you can keep polling a different table for a different response. Synchronous is your typical use case of I make a mutation, I want a response back immediately from the server. So there is no wait time. There is it's a blocking request, but that's your typical use case of writing some custom code. Asynchronous, you will probably end up using it in, let's say, a non-blocking use case of payments, where in your UI you will probably show like a progress indicator and so on. But in your calendar scheduling app, it will be a synchronous request. Most likely, as soon as you schedule an event, you want to send out invitations to all the members, right? So you don't want it to be an asynchronous event, right? So that's the kind of the event here. Um, so I'm going to go to the code gen here to try on glitch to create a simple Node.js server. Just going to look at some comments if there are any. All right, great. Cool. So the first thing is that we would want to have some boilerplate code created. If we finish this normal step of creating an action through a derive action workflow, we would have had this thing ready. So what I'm going to do is I'm going to recreate that step. We're just following this. Um, we already have the types defined over here in the custom types. So I'm going to skip that. So instead of create event, I'm just going to say schedule event, and I'm just going to leave this to the same one as this one. This would be create event. And I'm going to click on forward client headers. This is just purely done to generate some code gen automatically. So what this does is, as I mentioned before, if you do the derive action from the console GraphQL interface, uh, the console will intelligently pick up the types that are used for the original operation, which is the insert event operation, which is the one that you see over here, the highlighted one. I'm just going to zoom in a little bit. So screen is visible better now. Right. So this is the mutation that we initially wanted to try out in the GraphQL interface. This is just recreated, uh, and the console will generate code for doing the mutation post request. So this is just a fetch API call done the to make a post request to a GraphQL endpoint. It'll pick up the Hasura project URL as well, right? So this is just for doing some quick code gen stuff. I'm going to just copy paste this into my code. Right. So I'm going to make fetch API move to the top, probably even higher than Express. Yeah. And so this is just code from the boilerplate Express code gen. We have the Hasura operation defined over here, and we have an execute method, which actually makes a query to the GraphQL endpoint, accepts an operation for the JSON body, and also the variables, which we will send to the execute method. So that's what the execute method does. And if you look at the schedule event endpoint, what it does is it accepts the input object, the rec.body.input, and then you get it as an object, and you run some custom business logic over here, um, which would be about validating whether the event data is right and if the availability of the user is right. So that's some custom business logic over here, and there is some data and errors which will come back once you do an execute. So this execute method returns data, and if there's an error, we should ideally return an error. So that's what will come back from the mutation. And if there are errors, do return an error back to the upstream. If there is a success, return back the JSON that comes from Hasura. So that's broadly what the code gen does for you. You create a schedule, you create a post endpoint in your webhook handler, which does some custom business logic. and then we return back a response to the client. Basically, we return response, and then Hasura picks it up and then sends it back as a response for the GraphQL query of the mutation to the client. So if you remember, this is a HTTP endpoint. This is a REST API. This is a post request handling and serving at /schedule event or whatever endpoint this can be. And if you know the URL personally, you will be able to make a query to this post endpoint directly. So typically, to prevent that, we create a common shared secret, which will be passed in as another header. So typical use case would be um, shared secret, where you get in a value from the environment variable, which would be the shared secret for action. So we define a common environment variable between Hasura and your custom logic server, in this case, the Node.js server. And then in the headers, we will actually try to read the common secret. So, for example, I would do headers would be rec.headers. And in the headers, I'm going to parse the shared secret, then verify that with the environment variable over here. So that's how we typically do um, uh, a REST API being wrapped with a GraphQL type definition with Hasura, so that your REST API is not directly called from your client or from any backend, right? So if this REST API is hosted in the same cluster as your Hasura instance, then you can make this as an internal endpoint. Uh, and if it's a Hasura cloud use case, you can just configure a new um, env like a shared secret, and then just do some authentication between the two servers, right? So um, that's the initial setup that's required. Now moving on to the actual validation stuff and the schedule triggers bit, right? So go into some docs for schedule triggers. So if you're not familiar, if you're not used a schedule trigger before, it's basically just an event system where um, you can you can tell Hasura to run a particular event at a particular time. The event can trigger a serverless function. It could be like your microservice API, or it could just be an event queue that you're running and maintaining. So this is just to execute some custom business logic at specific points of time. And once so there are multiple ways to do this. If you go to the console, and if you go to events, I go to cron triggers or a one-off scheduled event, right? So there are broadly two kind of events that you can schedule. Cron triggers, as the name suggests, it's a cron schedule. If you've done cron jobs before, you can define a cron schedule at which a particular function can be repeatedly called on the given time schedule. So we can define a schedule based on the cron format. Like for example, a frequently used cron. Every minute, if you want to schedule something repeatedly, execute a webhook, we can do this. So I'm just going to create a simple test on, and I'm going to call the HTTP bin endpoint, which will just output whatever I give back as the input. So I'm just going to say input. So this is a simple payload object that I'm going to send. And this once I create this, this is a cron trigger. Once I create this, there will be events which will be scheduled for for the 1 minute time interval. Since our original configuration mentioned that this star 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 would be like uh, run this webhook endpoint every minute. There are other configurations, and if you're familiar with cron format, you can configure this. This is, I think, minutes, hours, um, and days and years and so on. So that's the schedule. We have events pending over here, and they'll start executing once the 1 minute time interval kicks in. And once you have the 1 minute finished, you will have the event triggered. With HTTP bin, obviously, this is the request response. The response would be whatever I inputted as a payload, which is the input from Hasura. So it comes back as the response. So we've just executed like one cron trigger example. So this in most cases would be useful for reporting. Um, if you want like a weekly or a nightly report email that you want to receive, process some data in the database, and then form like an email, nicely formatted email that you want to send across to multiple folks. That's when this kind of a cron trigger will be pretty useful, which is on a recurring schedule. This can be typically created using the Hasura console, and uh, and you can also include this in your metadata. So typically with cron triggers, which is a long-running cron trigger, you can include this in metadata, and once you move between different instances, or if you want to migrate to a different instance, this configuration will be migrated also to the new instance. So having this in metadata makes sense. Now coming to the calendar app, once you have uh, a one-off scheduled event, which is in a calendar app, once you book a time for a particular user for a, let's say, a 30-minute meeting, um, we want to execute one email reminder uh, uh, to be sent a few minutes before the event, and that will be sent only once, and that will be sent at a time interval with at a time which is just pre-configured and doesn't recur. So this is called a one-off scheduled event, where you just use a particular time uh, and execute one function, right? So this kind of a use case, you would typically not do it through the console. You typically want an API to schedule this, because just think of this use case where the event is created through our action in your Node.js code. Let's say once your event is created, as the response before you actually send the response back to the client, you want to make sure that you have scheduled some events to be executed in the future. So for that, we'll use the one-off scheduled event feature, but we need an API to do that. And Hasura gives you a create scheduled event API. So in our case, we would want to execute this API once we know that an event has been created in the backend, and before sending back the response to the client, we want to execute this API inside our action code, which will trigger this scheduled event. And and this doesn't need to be in your metadata, because this is something that will be executed once and it will be forgotten. So you don't need to like carry over this data in your metadata state. So typically, you don't want to include this data in your metadata state, because imagine having thousands of events happening between users, and there will be as many calls, as many API calls done to schedule as many events, and you don't want all of them in your metadata state, right? So this will be typically done through an API call and not through the console. But cron triggers, like which are probably like a one-time configuration, which is set and forget for like reporting kind of a use case. You can use the console and then include that in the metadata as well, right? So that's for cron triggers. In our calendar app, I think a cron trigger will be useful for a recurring event. So if you go back to the schema, you can see that there is a recurring flag, Boolean flag for an event. So if you have a particular event on a recurring pattern, let's say a daily meeting between two users, um, you can actually trigger a notification just a few minutes before. So to do that, we want to schedule this for the next few days, right? Which till the end date of this event looks like. So let's say this spans over a few months. Now you want to be able to schedule events for the next few months in advance, and then have this recurring pattern with the cron trigger, right? So that is the only use case where you might not want to include it in your uh, metadata, because uh, if you look at the payload, it will most likely have some user data in this kind of a use case. So in our example, for a recurring event to be scheduled to use a cron trigger, we need to know who are the attendees for that event. So we'll have some critical information like the user ID as part of the payload. So if I go back to the docs, um, and say create a cron trigger. So I'm just going to look at the API spec. So I mean, the name and webhook is fine, but if you look at the payload, for your webhook to send out emails to a user, or maybe even the user ID, so that the webhook can fetch the information, you will probably send in some very specific information about the user in the payload, and that is definitely not good to be part of your metadata. So you will probably use this create cron trigger HTTP post call from your action code, right? So that's a cron trigger use case. And then I think we'll look at one use case for scheduling one-off events. So I'm just going to open my Git repo. I have the server.js open. So if you look at this use case, right? The schedule event, the create event endpoint that was originally created. Um, we run some custom business logic with once the event is created. Uh, uh, we have we need to ensure that before the event is created, in fact, we need to ensure that the validation logic is taken care of. So we have some availability of the attendees logic. We'll also do some fetching of all the events of the attendees to do the availability check. So this multiple queries and conditions you will run through in your action before you actually execute the mutation call over here. So I'm just going to zoom in a little bit so that it's visible. Yeah. So so you will execute this Hasura operation, which is the mutation, the original mutation to the event table, right? And you will obviously give in the final object, which will be post the validation of all the stuff that you want to do and the parsing of the attendees data as well. And then you will pass in some headers, right? So in your execute method, if you look at it, it's just getting a Hasura operation, the variables, and of course the admin secret, and so on for inserting into the table, right? So this is so till here you will have validations to not allow this mutation to continue, and you will skip it. Uh, Once a mutation is executed, what you would want to do is you want to schedule events post the insert being successful, right? So this is where we have the create scheduled event object, and you have the arguments. So if you go back to the API of this, we have create a one-off scheduled event. Let's look at the API. So we have the webhook. We have schedule at, which will be the timestamp at which we want to schedule the event for, and the payload having some user information, right? So now going back to our code snippet. Um, so what we're going to do is we are just going to uh, do the start time. We have the moment library imported. And then what we're doing is we're just calculating the scheduling time, which is subtracting 10 minutes from your start date UTC timestamp column. So let's say the event is scheduled at 9 a.m. tomorrow. You are just subtracting 10 minutes before, and then you're making sure that a webhook is triggered at this particular timestamp, so that you can perform some kind of logic, which could be like sending emails or notifications or process some events in the background. And you send in some payload. So this payload will depend on what you want to do with the webhook. If you want to send in some emails, you want the user data, which is the user ID. Typically, once you have the user ID value in your webhook, you will be able to make a fetch query to get the user's email and any other metadata involved in the user. So that's the payload for you. This will be user specific information in most cases, or whatever table, depending on that, it'll be table specific information, and that's why you don't want this to be in your metadata, right? So once you schedule uh, an event at a particular time, you give in a webhook to be executed. This could be like a serverless function, or it could be the same Node.js server that we are writing in. This could be another endpoint over here. This is another post endpoint called scheduled event, and here you can obviously do some checking, validation before executing the notification logic, right? So that's the schedule webhook URL. You schedule it at a particular time, and you have a payload, which is specifically user data over here, right? So and then you have a fetch call to make a post request to execute this mutation. In fact, this is a REST API endpoint with Hasura itself. Hasura has a metadata endpoint, and this is how you actually schedule an event. So if I go back to this, the endpoint is v1 query. Typically with GraphQL, you have v1 GraphQL with Hasura. This is a metadata API call. So you will have to call the v1 query endpoint. Uh, Again, the query type is just JSON. You have a JSON request body, and if you pass in the admin secret, everything should work. So going back to this code, we'll actually send in an admin secret as part of the headers. So once you have an admin secret, this uh, metadata API will work, and you're just sending back the schedule a payload, the object that we just formed above the whole create scheduled event, right? So this is creating the event for us, and once that is done, we send back a response to the client, and then the client can show success message on the front end, right? So there are two ways to do this. Um, if in case you want to show something on the UI immediately after an event is created, after the validation logic is over, you can use our asynchronous event, where once you're creating an event, uh, you get back an ID immediately back from server, and you just subscribe to that event to see if the data is valid, or if the operation is completed successfully, and then do a check, right? So I'll just probably like show a quick demo of an asynchronous action by just using some default values, and then probably trying out example. Just gonna click create. We don't need to have a valid handler for that as well. What I'm gonna do is, since this is an asynchronous action, um, I can make a mutation. Just gonna remove everything. Mutation action name. I'm just gonna click. Um, and let's say I given some values, and I don't think it returns anything, so we can stick to just a mutation call. So if you look at the response over here, the Hasura server returns an ID, some kind of a unique ID for this particular event, and then the response was pretty immediate for us, right? So if I like do another query, you get an ID back very instantly. And what you can do is, on the front end, this is uh, a sign of the server accepting the request. But then the processing of the request will happen asynchronously, because let's say your logic is pretty complex and it'll take some time to execute. It'll, let's say, in some cases, it takes a few seconds to do it, and you don't want the UI to be blocked for a few seconds on that. So you will actually um, do this asynchronous logic. But in most cases, for our calendar kind of an app, we don't want an asynchronous logic. So this uh, the state of validation and parsing of the event data, this should be synchronous, and this shouldn't take uh, any any significant amount of time to execute on the code side. So the mutation can wait. The UI can wait on the front end for the validation to get over. Then you can execute the Hasura operation. Then obviously the scheduling takes place. If it's a recurring event, so we can do a check to see if it's a recurring event, and if it's a recurring event, schedule a cron job. So in that case, this create scheduled event would be create cron event, I guess. Going back to the create cron trigger API. So the API call will be slightly different. You will just call a create cron trigger, and you'll also tell the cron schedule at which this webhook needs to be executed. So depending on whether the recurring event and what the recurrence pattern is, so the pattern will give you, depending on the iCal RFC format, you can pass that format based on the frequency and the recurring interval, and then form a cron schedule for that, and then pass that as a value for your schedule value as in the cron format, and then give a payload, which is the list of attendees who are attending the event. Even if it's a recurring event, you can have multiple attendees, so you can have the list of attendees data coming in, right? So that's deciding between whether it's a cron trigger or a one-off event. And once you have this event processed successfully, you send back the data to the client. So that's the final bit of the process, right? So now the last missing piece is to understand cancellation. Um, so what if the user declines the event invitation? What about the event that is already scheduled to be executed? Right. So if I go to the events tab and if I go to one of probably cron triggers, this is a test cron, but let's assume that this was a cron trigger for a recurring scheduled event in the calendar. In this case, for all the pending events, let's say the event is cancelled, these events will not be automatically cancelled, right? A record insert into uh, the, let's say the event attendees status changes to declined. So you probably don't want to send them a notification for this user ID, right? So now, if this event gets triggered, what do you do? So there are two ways to handle this. You have a way to delete uh, the scheduled event, right, through the API, or you have a way to handle the execution of your notification system as part of your webhook custom logic. So let's say you have this webhook endpoint. Obviously this is the HTTP bin endpoint, but let's say this is your serverless function endpoint or your Node.js server post endpoint. Um, in that endpoint, what you would do is you would check if the status of the attendee is still uh, approved or open, and depending on that value, if it's a decline status, then you would not actually go ahead and send the notification. So the custom logic of whether to send a notification or not send a notification is still part of your scheduling webhook, which will be executed just a few minutes before the event. And if if any other events happen post the scheduled event happens, that's not under your control, so you can totally ignore that. But when the event is executing at this given scheduled time, at that particular moment, if either of these attendees have declined the event, then you should not proceed to send out an email or a notification. But the logic of that, the custom logic code for that, would reside inside the custom logic code which you have written for this cron trigger. So this webhook will have all the custom logic required for your particular event, and that's the whole workflow required for handling cancellations. So you don't technically cancel a scheduled event. The scheduled event still will run at the given time, but whether the attendees have accepted or not, depending on that particular state, you will be able to execute further in the custom logic side, right? So that will reside inside the cron webhook. So um, so that's mostly what I wanted to show you. Um, I have this blog post link for folks to check out. I'll drop this on the comments as well. I'm just going to put this as the reference link. Blog post reference. We already have the link to the GitHub repo for people to clone and then try this out and then try the Node.js function. This is just like a prototype example for you to handle an action, which is like the create event with a little bit of code gen code written for the derived action. But the fundamental idea is that you have two types of events with schedule triggers, and you choose to either store it in metadata or not, depending on how critical the information is in migrating. And and if it's user specific information, you typically don't include that in metadata. um, and and for the cancellation logic, you typically have the logic in place inside your webhook. So that's typically what we recommend to actually handle whether the further events like sending out an email will be executed inside the webhook of the scheduled event. So that's mostly the workflow. You have the database schema to refer to. You have the docs for schedule triggers. I'll just post the link for that. This will be schedule triggers docs. All right, so that's mostly what I wanted to show you folks today. Um, Feel free to post any questions, drop in comments on the blog post if you have any queries specific to scheduling. um, and then we can take it from there. So the permission system, I think we've covered for the tables, but once you have an action, you have to create permission for the action as well, which is again per role. Um, with 1.4 version of Hasura, I think you'll be able to granularly start selecting which fields to allow access to. And with mutation, it's just about executing the mutation or not. So in that sense, the permission is to allow access to do the mutation. And the select permission will depend on what the underlying permission for the event table looks like. We can have a relationship between, let's say, the created by value over here. So, for example, there is an object relationship which is called as the user. We'll go to the user table, and this will be the ID, and the ID over here. I think that is. So we have the okay, so event output, if we return back user ID over here, we can use that column for the relationship, right? Instead of the ID. This ID is actually the event ID. So we would want something like the user ID on the from column to point to the user's ID. So with that kind of relationship configured, you can start making queries, and then the underlying select permission will apply to your relationship as well. Cool. So if there are any questions, feel free to post in the comments on either the video or the blog post, and we can take it from there. Do try out the repo, try out the schedule triggers logic, and then see if everything makes sense on the custom logic side. And uh, so the fundamental premise is that you create an action and you create a schedule trigger to be created inside an action, and then you process events asynchronously through your action, right? So that's broadly what I wanted to cover in today's stream. Um, Thanks for joining in. Feel free to post comments, and I think that's it for today. See you folks in the next stream. I think next week we will probably be talking about um, Jamstack. Um, I'll come up with the exact title and then share it across on the YouTube schedule. And until then, see you folks. Bye bye.